Let's do question 1 of section B. This is for the 2019-2020 exam paper. Part A says, recall that an equilateral triangle has three equal sides. An isosceles triangle has two sides equal. A scalene has all three different sides, while a right angle triangle satisfies Pythagoras' theorem. Write down a Java program that will read three integer values from the user representing the length of the sides and then determines the kind of triangle they form. Hint, Pythagoras' theorem says that if A is the hypotenuse, B is the base, and C is the opposite, then A squared equals B squared plus C squared. So let's go ahead and solve this using code. I have here a project named question 1, and what I'm going to do is to create a triangle class. And this triangle class is going to have three sides. They are all going to be integers. So int A. So for side A, int B for side B, int C for side C. Then they want us to read three integer values from the user. So we have to use the scanner class here to read the input. And then once the user inputs these three integer values, the program should spit out the correct triangle, either an equilateral, isosceles, scalene, or a right angled. So let's go ahead and declare our scanner as well, that we shall use for user input. Scanner equals new scanner. The source here is system.in. Remember, every time you use the scanner, you must import the scanner class from the java.util package. So to solve this, looks like we're going to have 4 methods. One for the equilateral, the other for the isosceles, and so on. And these methods will be the ones to compute and do the math for us, and then spit out the kind of triangle that they form, depending on the user input here. So let's go ahead and create an equilateral method. So public void, let's call it equilateral. It's going to take nothing, and it will print out equilateral triangle. Equilateral triangle. But it will only do this if this dot a, remember this refers to the properties up here. This keyword refers to these properties. So it will only be an equilateral triangle if all these sides are equal. So if A is equal to B and B is equal to C. Because if B is equal to C and B is equal to A, then C is equal to A. So if that is true, then print out equilateral triangle. Let's do one for the isosceles. Public void isosceles. And this one prints out isosceles triangle, but only when two sides are equal. So if side A is equal to side B and side B is not equal to side C. So only two sides. That's one of the conditions. Or it could be if this dot A is equal to this dot C and this dot C is not equal to this dot B. Kind of repeating ourselves, aren't we? This dot A is equal to C and C is not equal to B, which is this. A is B, B is not C. And this is the same. A is equal to B and B is not equal to C, meaning C is not equal to A. Or we could have I feel like these two are the same. A is equal to C and C is not equal to B. A is equal to C. Okay. Yeah, those are the only combinations we can have, I believe. Yeah. So that's the one for the isosceles. Then the other was scaling triangle. So public void scaling takes nothing. The scaling is different sides. All sides are different. So if this dot A is not equal to, this is how you do the not equal to, like exclamation mark plus the equal sign. Then if you want to compare two values, you compare using the double equals like this. So if A is not equal to B and B is not equal to C, if that is true, then this is a scaling triangle. So let's do the last one, which requires us to compute to use Pythagoras' theorem. So public void right angled So first, let's compute Pythagoras' theorem. So to make this easier to our eyes, I'm going to say an integer a is equal to this dot a, and an integer b is equal to this dot b, and an integer c is equal to this dot c. I can do this because we have the same variable names here, but these variable names are not the same as these ones here, because these ones are now local variables because they are scoped. They are within this scope, within the right-angled scope. And to reference these ones, remember I said we have to use the keyword this. which is what we are doing here. So the local variable a is equivalent to whatever is in this dot a, whatever is in this property here. So after doing that, I'm going to say I'm going to declare no, I'm going to say it's a squared. Let's see if a squared, okay. Let me write it here for reference. A squared equals b squared plus c squared. Okay. So let me first do this part, which is going to be, so we cannot square, we cannot do something like this. You cannot square like that in code in Java. So there's a method on a utility class called math. This math that is shipped with the JDK. So there's a method called pow, P-O-W, for power, and it takes two values. The first one being the base. So in our case, b, which is that, and then the second value is the power, what you want to power it with, and in our case it's squared, so b squared. And this math library has to also be imported, just like we imported the scanner. Oh, don't have to, because it's part of the JDK, so don't really have to import it. So we get that math.pow again, and this time we are squaring c, so c squared, like that. And all this is going to be stored in the variable a, this one here. Now here it's complaining because this, it's saying the required type is an int, because we have ints here, so it's expecting an int, and we are providing it with double values, meaning this .power method returns doubles. As we can see here, it returns the value a. Okay, yeah. So here the arguments it takes are double values. These ones, they have to be double values. So we can fix this error by doing this. And these are converted into doubles, the ints here, these ones here. When this is done, they are converted into doubles. So we have the formula there, Pythagoras' theorem. Now what we need to do is to print right-angled triangle if this is true. So how do we tell this is true? If okay. Let's not make this a. Let's give it its own local variable. Let's call it int expression. No, it's a double expression, like that. Remember, we have to square a as well, a squared, like this. So if let me also do the math here. So a is equal to math.pow a squared, like that. Oh, this is this dot a. Oh yeah, because yeah, okay. So this becomes if a is equal to the expression. So if the square of a is equal to the sum of the square of b plus the square of c, which is stored in expression. So if that is true, then print out equilateral triangle. So those are our methods, 4 of them: equilateral, isosceles, scaling, right angled. Now we need the main method to run this entire code. So I'm going to write the main method below here, psvm, and now I need to create an object of type triangle. Let's call it triangle is equal to new triangle, like that. Now remember, when we are creating this object, we need to take user input. We need to take side A, side B, and side C, like that. And to read user input, we can use the scanner class, which we declared above here. So let's get that scanner class on the object rather. Scanner. Let's first create a local variable called A, and this will be the value that we get from. That's not happening. Sorry. So let's make scanner static. See if that, okay, that does it. So scanner.next, what are we reading? We are reading integers because you can't, okay, you can't set to point. Let's read doubles. Next double. So then this does not become an int, becomes a double. So whatever that is, whatever the result of this, the result we get from the keyboard, use it in this constructor to create the triangle. Then the other double B, the scanner dot next double. Then double C is scanner dot next double, like that. So we have our user input. Now we need to overload this constructor, because Java gives us a default one, which is this one, compiles fine, because when you don't declare or define your own constructor, Java gives you one, the default one, without arguments. But since we want to create a triangle with the sides already, let's create our own constructor up here that will take those 3 arguments. So public triangle int A, int B, int C. So this will initialize the properties, this property is above here. So that property will be whatever we get from the argument A, and the same for the other 2, like that. This dot C is equal to C, like that. So now here, these are integers, it's supposed to be doubles, okay. This entire thing is causing problems. Double ints, we are getting confused along the way. So I'm going to make a decision and change everything to an integer. So this will go back to an int, because I don't want it. I'm not going to test for centimeters. And then this means I can cast oh yeah, I have to cast this as a double. Nope. A is an int, this is a double. cast it into one int. Okay, yeah, because we're not going to use the decimals, fractionals. So then this also becomes integers, and then these become next int, like that. So now we have no, okay, we have this one, because this is a double, so it has to be cast into an int. Okay, let's do this and that. So the entire expression, this entire summation of b squared plus c squared will be cast into an int, which will be stored in the integer expression. So now everything is compiling fine. Now let's call our methods on this triangle object. So we have equilateral, we have isosceles, scaling, right angled. So if I run this code and input some values, I should get either of these. So our input is going to be, let's try an equilateral one. That one is easy. Same values. Equilateral triangle. Let's try different two equal sides. One is different, so 3, 3, 2. That's an isosceles. A scaling is when you have all sides different. So that's going to be all sides different, 5, 4, and 3. Now we get a scaling triangle and an equilateral triangle. Oh, wait. Oh, now let's make this very clear. So we don't get confused. This is going to be side A. Then this will be side B. And this will be side C. So here, if I run 543 again, five, 4, 3. So 5 squared, because this is 25. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. Yes. Okay, so this satisfies both scaling and equilateral. But equilateral? No. No, this is a right angled triangle. We run this, we run this. It's not an equilateral, it's a right angled. So 5, 4, 3. Now, if you know what a scaling triangle looks like, it does not have a right angle. So we have to make sure we don't print a right angle when we get values, different values that satisfy the Pythagoras theorem. So to do that, we need to go to the scaling method and say if this is true, if all the sides are different, which in our case they are, and those sides, so basically get this entire thing, make it's embed it like that, and say and Now our AND is going to be similar to this here. So we can just get this. Where are we? We are here. Like that. So fix this dot. Not too many. So fix that. Make them refer to the local variables just to make the code cleaner. So if this is true, and what else we want to test for is, I'm going to have an int called basically the same thing down here. This entire thing to test for what? For right angled triangle. Oh, wait, I can just call the method. So if I take everything, okay. Yeah, take everything back to how it was. Like that, like that, like that, like that. So if this is true, and and I want to call the right angled triangle method and right angled like that. So we cannot call it like this because we don't have an object on which to call it. So I can just make this static like that. And I don't want it, I want it to return either true or false. So this becomes Boolean. Like that. And then there's this, you can't call static what? Can't use this difference, this reference in a static method. Oh yeah, we can't make it static because we are using these properties here. So okay, we can't. Okay, that won't work. That won't work. So yep. So let's go for this as it was. But trying to find a way to avoid duplicating this code. Let me see. Let me make this return a Boolean value. So if it's a right angled triangle, return true, like that. Otherwise, return what? False. If it's not a right angled triangle. Now, in our scaling, if this is true, and oh yeah, I forget we can't call the the method. Okay, let's just duplicate the code. We can return void as before. Grab this entire thing. This is paining me. Put it here. Like that. So if it's a right angled triangle, what am I trying to do? Oh, okay. So let's get rid of this if statement. What I'm trying to do is to say if all sides are different. So if it's scaling 5, 4, 3, if all sides are different, like this condition here, which can now be simplified as if A is not the same as B and B is not the same as C. If that is true, and A is equal to the expression. That's another condition we have. So basically, if all sides are different and it's a right angled triangle. Wait, and not, so we have to note this like that. So if all sides are different, 5, 4, 3, those are all different sides, and it's not a right angled triangle, which is this bit here. Because you can't have a scaling triangle with all sides different having a right angle. That's impossible. So if all sides are different and it does not have a right angle, then it becomes a what? A scaling triangle. But if it has a right angle, basically, of course, the sides have to be different here. So if it has a right angle, then it becomes what? A right angle triangle with this method called. This one just uses the Pythagoras theorem to negate the condition, to make sure it's not a right angle. So if I run this again, I should just get scaling triangle as the only output. So 543 gives me, 543 will give me the right angle, not the scaling, because 543 will have a right angle, because that follows Pythagoras' theorem. 5, 4, 3 will give me a right angle. But if I have different sides that do not follow Pythagoras' theorem, like 5, 4, and 2, we get a scaling triangle. So that's part A. Okay, let's do all of them one more time, all 4 of them, to make sure everything is running fine. So we have 2, 2, 2 to get an equilateral. Then to get an isosceles, we have 2, 2, and 1. Oh, another bug. So this should only print isosceles, right? Because scaling is all sides must be different. So you need to do that as well as an extra condition here. So we have trying to make it look neat. We have that condition. Nope. That condition and that condition. Nope. Have that condition and scaling. Isosceles is only 2 sides. Oh, it's basically this entire thing. Wow. Okay, grab that. Copy. Create 2 brackets to hold whatever I'm going to paste. Like that. And doing that is, I think there's some repetition here. Yeah, this and this are the same. So we can get rid of, let's get rid of this entire one. That. Zero is true when reached. Because we have it here. So if A is not equal to B and B is not equal to C, what if we just say and A is not equal to C, like that, saving us from all this extra code. Yeah, that should work. So so A is not B, B is not C, and A is also not C. Like, there's no similarity there. So if we run 2, 2, and 2, that's an equilateral. And if we run 2, 2, and 1, that is an isosceles. Oh my goodness, still get a scaling triangle. How? Isosceles. All sides must be different. So A is not B. A is not equal to B. B is not equal to C. A is not equal to. So for some reason this is being skipped. Oh wow. Our condition here is kind of false. So if A is equal to B, A is equal to B, and B is not equal to C, which is true. So it will print isosceles, which is supposed to, or A is equal to C and C is not equal to B. So this is true or false, which will print true. So it will print this. Are we getting scaling triangle? Our condition here is flawed. What if I add extra brackets like that? Maybe there's some precedence issues going on. Try 2 to 1 again. 2 to 1. If A is not equal to B, and so here we have A is not equal to B, this is false, and B is not equal to C, this is true. So false and true is false. So this entire thing is false, and A is not equal to, so this is true and this is true. So false and false is what? False and false is false or true. False and false has to be false. Google. False and false is okay. False and false is false. Whoa. Which incoming changes do I have? Let's cancel that. Basically, this thing should not be running. Okay, debug mode. Debug. Where are you? So what I want is this expression and whatever this is. This has to be true. Oh, getting okay. Let's include that as well. Okay. So this is 2, 2, 1. This is true. True and true is true. The entire thing is true. True, 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 true. Oh. Oh. Because A is being squared here. Oh, interesting. Interesting observation. Okay. Instead of using A, let's use int A squared, like that. Meaning A squared should be the one to act there. Also meaning, stop the debugger. Thanks for debugging. Let's go to the other one. This is okay because, yeah, whatever A becomes has to be squared anyway because we are using the Pythagoras' theorem. So it's only here where we needed to separate these A's, these ones, which were referencing to the actual number that was input by the user and not the one that is computed after squaring. So running this again should only print isosceles when it's 2 to 1. 2 to 1. Moment of truth. Yeah. Oh, wow. Okay. Feels like I have to do the entire thing again. 2 to 2 equilateral. Then 2 to 1 gives me isosceles. 2 to 1. Then the scaling one is all sides different. So 1, 2, 3. Equilateral is I mean right angled. 5, 4, 3. Good. Okay. Okay. So let's go to part B. Part B of the question is saying Mr. Mukasa has a rectangular piece of land that he wishes to divide. Looks like, man, this entire question needed you to know some mathematics. You saw me Googling stuff and maybe some truth tables. Mr. Mukasa has a rectangular piece of land that he wishes to divide in small rectangular paddocks. Rectangular piece of land, small rectangular paddocks. In order to properly graze his animals at the farm, the small rectangular paddocks must be of equal size area. Yeah. You are required to write a Java program that will request Mr. Mukasa, that will request, meaning you have to use a scanner, to enter the length and width of the small paddocks, the length and width of these small rectangular paddocks. Then the program determines the area of each small rectangular paddock. We enter the length and width Then the program determines the area of each using a method which you must later call in the main. The program should print the size of each small paddock and the total area that Mr. Mukasa needs to make 100 paddocks. Oh my goodness. Actually, I remember this kind of question in my level. Oh my goodness. Okay. Well, there's going to be some googling involved, maybe. I don't know. Let's try this code. So let me just create a new class. Call it paddock. So they require us so we need to have the length and width, then a method to determine the area. So int length, int width, then a constructor public paddock with the arguments that will be used. So these dots and these dots. We also need to create a method to create the area, public void area of small paddock. This area is going to be let's create another property called area up there, which we shall reference like this, and that area is the area of whatever our length is going to be, whatever Mukasa is going to input as the length times the width. Then the program, we must call this method later in the main method. So the program should print the size of each small paddock. And the total area that Mr. Mukasa needs to make 100 paddocks. Okay. So after calculating the area of the small paddock, we need to print out that area. So this will be the area of each small paddock. Now, after printing out the area of each small paddock, what's the length of the farm? What's the size? What's the total area that of the entire rectangle that will contain those small paddocks? What is the total area? If we need to make 100 paddocks, what would the total area be? So if we need 100 paddocks, what is that hinting at? If we need 100 paddocks, Okay, my head is stuck there. Let's go to Google. Paddock problem. Maths. Oh, a farmer's paddock. Something like this, I think. Something like this. Oh, wow. I might end up first pausing this and going through this question. If we need 100 paddocks, so 100 of these. What's the total area that is required? Could we maybe just multiply this times 100? I don't think that fixes the problem. Anyway, okay, let's first go on. Let's create our main method. Create the paddock object of type paddock. It's going to be our new paddock, taking in these arguments that will be picked from the scanner. So scanner system.in, and our length will be scanner.nextInt, and our width will be scanner.nextInt as well, because we're processing integers. And then the constructor will use the length and the width to construct the paddock object. And then this paddock object will call the area of small paddock method to calculate the area of one small paddock. Let's say small paddock area, and that will be that. So if I run this and me as Mr. Mukasa inputs the area as 10 meters as the length and width of 4, that's a very small paddock. So small paddock area is 40. I don't want to butcher this one. Looks like the total area is going to be whatever the area of the small paddock is times 100. Mathematics. Math. The program should print the size of each small paddock and the total area that Mr. Mukasa needs to make 100 paddocks. Okay, so let us shout. that to make 100 paddocks, total area is boom boom, whatever the area is, times 100. Run. So if our length for the small paddock is 10 and the width is 4, the small paddock area is 40 for each. Small paddock area is 40, so each paddock has an area of 40, whatever this is, meters or centimeters. Can't be centimeters, that's too small, so meters or maybe feet, I don't know. To make 100 paddocks, total area is I'm not satisfied with this answer. Feels like there's much more to the question, but given that it's I believe. Let me know your thoughts in the comment section. That's my solution, because I don't see any other way to get this area that you need to make 100 paddocks. It seems logical. It has to be whatever this is times 100. Okay. That's it for question 1. If or when I get the right solution, I'll have to update this video, of course, and let you guys know. But for now, that's my solution. Okay.